Hello students, good morning. This is the video for section 8.2. I'm going to do that in two parts. The first part will just go over the general overview of testing claims about the proportion. Okay, so we'll be setting up, and then the second video I'll go through specific examples. I'll look at each of the type of test we have. That's a true tail, right tail, or left tail. Okay. Now, at the end of this section, we should be able to use the p-value method and then the critical value method to test claims about the population proportion. Okay. Now, we will use both the formulas and then the StatCrunch, and mostly I will use the StatCrunch to do the same things. Okay. So, what's our objective? That is, you want to conduct a formal tests or hypothesis tests of a claim about the population proportion P. Okay, that's our objective. And then the notations, as we mentioned before, are the same in the 8.1. Okay, the sample size, your population proportion, which goes to the null and then alternative hypothesis. Your Q is 1 minus P, and then the P hat is the sample proportion is given by our X over N. Now here, what is your X? X is the what? The number of successes. And number of what? Successes. Okay. Okay. What are the requirements? There are 3 requirements. Okay. For it's a binomial distribution, and this is an approximation to that. So the sample observations are all simple random. Okay. That it means every outcome has the same chance of being occurred. The second requirement is that is a condition of a binomial distribution. Okay. Now there is a fixed number of trials. So if your n is like 10 or 20, fixed number of trials, and all the trials are independent. Okay, they are all independent. And each trial has 2 outcomes, a success and a failure. Okay, that's why we denote the X by what? The number of successes. And then the probability of success remains the same in all situations. Okay, so your probability of success in this case, we are going to use what? Either P, you're going to use P for that as a success for each situation. Okay. Or if you use the sample proportional estimates for that, you get the same thing. All right. Now, what's the third requirement? The required requirement is that N times P is greater than what? Or equal to 5, and then N times Q is greater than or equal to 5. Or we say that there's at least what? 5 successes and then 5 failures. So in other words, your P in this case is not your sample proportion. This is a P under what? Under the HO. Okay, so if your HO is stated as P is equal to 0.5, then this is the P that we are dealing with. Then of course the Q of that is 1 minus the P. So in this case, if you use this example, then that is 0.5. Okay. So there are 3 requirements. Okay, 1, the samples are simple random. Okay, and they satisfy the binomial distribution requirement. That's all. It has a fixed number of trials. Each trials are independent. Each trial has 2 possible outcomes: a success and a failure. Okay, and then each probability of success is the same for every trial. Okay, so when this happens, then we approximate. It's a normal approximation. Okay, it's a normal approximation. And then the test statistics is given by what? This formula right here. So this is a Z test statistic. Now, if you remember in this section 8.1, I did what? If I watched that video, I did use this formula to calculate that. Now again, this P we have here, this P, okay, it is what? The P, the test value under the what? The null hypothesis. So if your P is what? 0.4, then that is what the P is about. And again, its Q is what? 1 minus the P. All right. So if you have all the three requirements satisfied, then we use what? A normal distribution. That's using Z table, and then to find what? To test the claim. All right. Now, for a p-value, all right, for p-values, we can use the technology of start current to find p-values, which is easy. And then we can also use the table, that's a normal distribution table to find a p-value. And I'll use both for each example that we consider. The critical values too, we can use the table or use the start current to find. For the critical values, you can use the start current to find that, or use the table to find that also. Okay. So, what is each word, each approach? We mentioned this before in section 8.1. Okay. Now, for each test, you have to what? First thing is that you state your null and alternative hypothesis. You have to decide on what? Significance level, which is the alpha. You compute your what? Test statistic, which in this case is the Z test statistic. And then you calculate your p-value. P-value is a probability, okay? It's a probability. So you cannot have this value. The p-value is always, it is between, it's less than or equal to 1 or greater than or equal to what? 0. It's between these values, okay? Now, how do you decide, that is a step 5, that if your p-value is less than or equal to the significance level, alpha, we reject HO. Otherwise, we do not reject it. And then, of course, finally, you state your your conclusion in the context of the problem. Okay, so these are the various types of tests that we may have. We have what? The two-tailed test, the left-tailed test, and then the right-tailed test. Okay, now when you use the p-value method, irrespective of any of these what tests, your decision is always that the p-value, if it is less than or equal to alpha, okay, if it is less than or equal to alpha, then what? You reject HO. Okay, that is the p-value. That's a decision. If p-value is less than alpha, less or equal to alpha, which is a significance level, we what? We reject what? HO. Okay. Now, if you use the critical value method or approach, the first 3 steps are the same as I mentioned in my previous video. Okay, the first 3 steps are the same, but your 4th step is different. Here you have to calculate your what? Determine your critical value or values. The critical value is 1 if it is either left tail or right tail, but it's 2 if it is what? A two-tailed test. Okay. Now, how do you decide? Step 5 is a decision. If your test statistic place, okay, falls in the rejection region, then we reject what? HO. Otherwise, we do not what? Reject. And then we interpret our results. Okay. Now, your decision is quite a little bit different because each type of test has a way to decide, using either to reject the HO or not. Now let's talk about the two-tail. Now two-tail test, if it falls in at the tails, okay, if your test statistic is, again, remember, Z alpha and minus Z alpha are your what? Your critical values. Okay, so negative Z alpha is a critical value for the left tail, and then Z alpha is what? the critical value for what? For a right tail. Now, if your critical value, assuming you calculate your test statistic, okay, let's denote it by Z. If your test statistic, okay, is positive, now for a two-tail test, we're going to compare it with what? This critical value. Now, if it is negative, you want to check that if, let me write this down. If Z, okay, if Z, that is your test statistic, is greater than positive Z alpha by 2, you reject what? HO. Now, if this test statistic is what? Negative, okay, then with the Z for two-tail is less than, if it is greater than equal to, it's less than equal to what? Z, sorry, negative Z alpha by what? By 2. In that case, 2, you reject what? HO. Okay. Now, if you have a one-tail test, if you have one-tail test, okay, if you have a one-tail test, then this is what happens. Okay, if you have a left tail, if you have a left tail test, okay, so let's talk about how to decide that. If you have a left tail test, okay, look at the rejection region is this side. And so we're going to compare with the negative. It's the same as comparing with the what? The negative Z alpha by 2, except that this case, you don't find Z alpha by 2, just alpha. Okay, so how do you decide if, okay, if your Z, that is, what's your Z? Your Z is your test statistic. If it is less than or equal to negative Z alpha, reject what? HO. That is for a left tail. Now, for a right tail, if the test statistic is what? Greater than or equal to the positive for alpha, that's your critical value, then reject what? HO. This is for a right what? Tail. Okay, and so we consider examples and see how we work. We will use this to decide whether to reject or not to reject the null hypothesis. Okay, so I'm going to stop here, and we'll go over this example and then others that we'll be talking about in the future meeting. Okay, all right, thank you, and I'll see you in the next video.